Hello, welcome to another class with Physics Anchor. Today we'll be solving some questions under the topic motion from JAMB past questions for those that will be writing JAMB. So let's get started. Uh, we have two questions, okay, that relate with velocity time graph, and I want you to pay a very good attention to these questions. So the first one, the graph below describes the motion of a particle. So this is the graph, okay. The acceleration of the particle during the motion is dash. So they want us to know to calculate the acceleration during the motion. So this is the part that shows the acceleration, okay. This one is deceleration. This is the part that shows constant velocity. So if we must find the acceleration, if we must calculate the acceleration of the particle, then we can say, let's begin with this, the solution. So we can see that here the particle did not start from rest. So you can see this mouth here. You will see that what? Here the speed is actually 2 meters per second square. So that's 2 meters per second rather. So the initial speed here is 2 meters per second. So that means that our u is not 0 but 2 meters per second. In other words, this particle did not start its journey from rest. It was actually moving before it accelerated. It was moving with 2 meters per second first. So, and our final speed, if you trace it, the final speed after the acceleration is what? 10 meters per second. So our v is equals to 10 meters per second. So during this journey also, the region of what time here, it means that the acceleration lasted for 2 seconds. So you can see the acceleration lasted for 2 seconds. So that means that our time there is actually 2 seconds, and they're asking us of acceleration. So having this, the formula we'll use become what? Easier. So we can say that v equals to u plus 80. We are using this, okay, because of the parameters. So our v is 10, our u is 2, plus we are looking for acceleration, our t is actually what? 2. So that means that we have 10. Let's bring this 2 here. That will be 10 minus 2 equals a times 2 will give us 2a. That will be 8 equals to what? 2a. Our a now will be 8 divided by 2, which will be what? 4 meters per second squared. Okay, so let's look at our options. Not A, not B. Okay, that is what? C. We have 4 meters per second squared. So that will be the correct option. I hope you understand that. So let's move to question number 2. In question number 2, okay, the diagram below, this is the diagram, okay, shows a velocity time graph representing the motion of a car. Find the total distance covered during the acceleration, the distance covered during the acceleration, which is this region, and retardation periods of the motion, and the distance covered during the retardation period. In other words, we are going to find the distance covered during the acceleration. We find that one during the what? Deceleration, and then we add it together. That's what they want us to find. Okay, let me make this to be perpendicular very well to that line. So let's first deal with this. According to this journey, so we can see that the object here actually started moving from the origin, and that means that what? It started from rest. So the line of the acceleration began from origin. So it started from rest. That means that u equals to 0 meters per second. Our acceleration, if you trace this to this place, you see that what? The acceleration, okay, ended when the body or this car, when it was attained the velocity of what? 10. That means that what? V, final velocity, is actually 10 meters per, okay, seconds. And then we can say that our acceleration in that place, okay, we don't even need to calculate our acceleration. If you look at the question very well, all we just need to do is to get our distance. So since we already have what, this 10, we have this 10. We know that the area under the what, velocity time graph is what will give us what, the distance. So that one has what, come out like this. So from here to here is 10, that is 10. And from here to here they have given us, that is 10. So very fast we can even do that by saying that what, that's distance during the acceleration now will be area of this what, triangle, which is what, area of the triangle, and that will be half times base times height. This is our base, this is our height. That will be half times 10 times 10, and that will give us, half times 10 will give us 5, 5 times 10 will give us 50 meter. Okay, so the distance covered during the acceleration is actually 50 meters. So what we are looking for is S acceleration by the analysis I did in that place. So during the deceleration also, when you look at the deceleration, okay, the height, okay, let me bring out the triangle also for you to see. So it's like this. So distance, I've told you in the last, in a particular video I did, explaining that what distance under the velocity time graph is actually the area under the graph, okay? And because they just want us to find the area, distance during acceleration, distance during deceleration. So just bring out this triangle, that one is the area during acceleration. Bring out this triangle, that one is the area under deceleration. So the area here, okay, if you trace this place very well, you see that it's also actually what, the same 10. So this place is 10. But this place, when you trace it out, you can see that it's not on 50, it's in between 40 and 50. So what is here is actually 45. In other words, the gap here will be this 45, okay, 45 that is here, okay, minus this 40, okay, that's 45 minus this 40, that will give us 5. So the area, which is S deceleration, let me call it deceleration, distance during deceleration will be area of this triangle, okay, and that will be half times base times height, which is half. Our base here is what, 5, our height is still what, 10, okay, and that will give me 25 meter. So total distance that they're asking us, that's the distance covered during acceleration and deceleration, will now be acceleration distance plus deceleration distance, and that will be 50 that we got here plus 25 that we have here, that will be 75 meter. So let's check our option. So that is A, staring at us right there, 75 meter. So train yourself to list out parameters, so you will see even the information that you need and information that you do not need, information that you need to find and information that you do not need to find. You can see that while writing out my parameters, I quickly cited, okay, fine, I don't even need to find acceleration because looking for my acceleration will be a waste of time here. So I just need to find the distance covered during acceleration, which the area under the graph, this triangle will definitely give me. You can see that this is a right angle triangle, okay? So and that's how to go about the questions. So we are through solving these two questions under velocity time graph in motion, and I hope you have a good understanding of what we have done just now, so that if you see any question like this, you can easily approach it with the knowledge that you have gained from solving these two past questions. Hopefully I will still be bringing more questions in this area so that you can actually perfect your knowledge in solving problems relating to this aspect under motion. Please share out these videos with other students around you, hit the notification bell, subscribe, share out, like this video, comment, and let me know how well you are doing studying with Physics Anchor. Till next time, I will be coming your way. Remain blessed, and I wish you all the very best in your examination. Bye for now.